Hi, Miss Lindsay here. Today we'll be talking about solving equations by clearing the fractions, or in other words, fraction begone. And we have the math wizard here, the fraction begone wizard, here to help make all your fraction problems go away. So let's get into it. We all know that fractions are annoying. However, if it's an equation, and only if it's an equation, we can make those fractions go away by using the LCM, the least common multiple, or in this case, because they're fractions, the least common denominator, the LCD. All we need to do is find a number that both 2 and 5 divide evenly into. That's called the LCM, and in this case, it's 10. If I multiply 10 to both sides of this equation, and I distribute, that's why I like to call it multiplying through by 10, I'm going to make these fractions go away by reducing. So 10 divided by 2 is 5. So here I'll get 5x. And 10 divided by 5 is 2. So then I'll get plus 6. And here, I could have written this 3 over 1, but it's not really a fraction. There's nothing to reduce. So all I do is multiply 10 times 3, and I get 30. Now I have an equation with no fractions that's quite easy to solve. I subtract 6 from both sides. I get 5x equals 24. And when I divide by 5, I get x equals 24/5. Now there's no reason to change this fraction because that's the solution. It's not bothering you. The only time a fraction bothers you is when it's in the original equation that you have to solve. You can check this by using your calculator, and your calculator can quite easily handle the fractions as long as you substitute for x in parentheses. So I substitute 24/5 in for the x, but make sure you put the whole 24/5 in parentheses, as I've done here, and you end up with a 3, which matches the 3 on the right side of the equal sign. So you know you've done that correctly. Let's try another one. Here we have an equation with two fractions, 5 and 3. And I'm going to make those fractions go away by finding the LCM. 5 goes into 15 3 times, and 3 goes into 15 5 times. If worse comes to worse and you can't find the least common multiple, you can always multiply the two denominators together, and that will give you some type of common multiple. Maybe not the least common multiple, but it'll give you something that will work. In any case, I'm going to multiply through by 15, and when I do that, I'm going to make the fractions go away because 15 will divide out both denominators. So when I divide 15 by 5, I get 3. When I divide 15 by 3, I get 5. When I clean that up and multiply, I have 15x plus 6 plus 6 equals negative 5. If I solve that, subtracting 6 from both sides and dividing by 15, I get x equals negative 11 over 15. I definitely would not want to change this to a decimal. It would be a nasty repeating decimal. It would be even harder to check. Your calculator can quite easily handle the check. And again, all you need to do is check on the calculator. You don't need to show us this on paper. So your calculator, as long as you substitute your solution for x in parentheses, your calculator can quite easily handle the fractions. On the left side, you get negative 0.3 repeating, and on the right side, you get negative 0.3 repeating, which are both 1/3. So let's try another. Here we have 3 fractions. So all we need to do is find the LCM, or the least common multiple, of these 3 denominators. Now I could multiply them all together and get 36, but that would be overkill. If you notice that both 3 and 2 divide evenly into 6, we can just use that as our LCM or LCD. We want to use the least common denominator if possible. It will make things a lot less complicated. So we'll multiply all 4 terms in this case by 6. They should all cancel out the denominators. 3 goes into 6 twice. This one's not a fraction, so we don't have to worry about it. 2 goes into 6 3 times. That's 3. 6 goes into 6 once. When we clean all that up and multiply, we end up with 4x minus 12 equals 9x plus 1. We have variables on both sides of the equal sign, so we'll have to take care of that. And I did that by subtracting 4x from both sides. Getting negative 12 equals 5x plus 1. Solve by subtracting 1 from both sides. Get negative 13 equals 5x, and when I divide by 5, I get negative 13 over 5. Again, I'm not going to bother changing that to a decimal. It's not necessary. All I need to do to check is to substitute it in parentheses for both the x's. So on the left side, I substitute negative 13 over 5 for x, and I get negative 3.73 repeating. And again, don't delete that. Leave it on the screen so that you can now substitute on the right side of the equal sign. Make sure you substitute negative 13 over 5 in parentheses, and you get a matching solution. Okay? Both sides will balance. That's how we know we did this correctly. Now, what about parentheses? Here's where you have to be very careful. You don't want to go right to getting the LCD, because even though 2, 9, and 27 do have an LCD, it's 54, we don't want to use that because we are not allowed to break the LCD or LCM into that bubble. We would only be able to multiply it by 3 over 2. You could do that if you want, multiply both sides by 2. But what I did instead was I distributed 3 over 2. And if you use the math frac feature on your calculator, so you would type in 3 over 2 times 5 over 9 on your calculator, you get this repeating decimal, 0.83 repeating. But if you go to this math button, you'll come to a menu called Math Frac. It's the first option. If you hit enter, it'll ask you if you want your answer as a fraction. Hit enter again, and there it is, 5 over 6. Do the same thing with 4 over 27, and now you'll have 2 nice clean fractions. And then all we need to do is solve that the same way. Now we need to find the LCD or LCM of 6 and 9, and that would be 18, because 6 times 3 is 18 and 9 times 2 is 18. Multiply through by 18. 6 goes into 18 3 times. 9 goes into 18 twice. Clean that up. You get 15x plus 4 equals 54. When we subtract 4 to both sides, divide by 15, we get 50 over 15, or reduces to 10 over 3. Again, you can use the math frac feature on your calculator if you'd like to reduce 50 over 15. And of course, when we check, on the calculator, we're going to end up with 3. So when you have parentheses, please do not multiply your LCM inside the parentheses. Do not break the bubble. What you need to do is distribute using the MathFrac feature on your calculator, and then go from there and find the LCD. Okay, what if we have a variable in the denominator? Well, we're going to do the same thing. We're going to find the LCM, but this time we need to find something that x divides into. All right, and that's pretty simple. It would just be x. We would do the same thing with the 9 and the 3. All right, what's the LCM of 9 and 3? Well, 3 goes into 9, so it would be 9. So your LCM would be a combination of the variable and the coefficient. So your LCD or your LCM is actually 9x. So we're going to multiply both sides of the equation by 9x. And what I would like to do is make sure I get every term multiplied by 9x. So I'm going to write a 9x up here. So I have 9x times 7 over x, 9x times 2 over 9, and 9x times 5 over 3x. When I simplify, x and x will cancel, but the 9 will stay. So I'll have 9 times 7. The 9 and the 9 will cancel, but the x will stay. So I'll have 2 times x. The x and the x in the last term will cancel, and 3 goes into 9 3 times. So I'll have negative 5 times 3, which is 15. 9 times 7 is 63. I have left the 2 and the x, so it's 2x, and negative 5 times 3 is negative 15. So I would solve this the regular way by subtracting 63 from both sides. Get a better color. Subtracting 63 from both sides. That would give me 2x equals negative 78. Then I'm going to divide both sides by 2. And that gives me x equals negative 39. So x equals negative 39 is my solution for x. To check, I would substitute negative 39 in for both x's. So I would substitute negative 39 on the left side, 7 over negative 39 plus 2/9. And I would substitute it on the right side, negative 5 over 3 times. And remember, this whole denominator, you need to put that whole denominator in parentheses in order for the calculator to work properly. So the 3x is going to be a whole unit. So you need to put that whole 3x in parentheses. Again, let me show you that a little bit better. Notice how here I substituted the entire denominator in parentheses. And then your calculator will give you matching values. Here's a challenge. I have denominators with fractions, and I have a couple of variables in the denominators, but this one is a binomial. So immediately what I do is put that in parentheses or put it together as a package. So this x plus 2 is a package. It runs together. So this 2 has nothing to do with this 2 over here. All right, now this 2 and this 4, I can find an LCD. 2 goes into 4, so 4 would be the LCD. But I need to handle this x plus 2 as an entire unit. So my LCD is 4 times x plus 2. So remember, these two things have to be handled separately. The x plus 2 is its own package, its own binomial. The 2 and the 4, you find the LCD exactly the way we found the LCD of the previous problems. So we're going to multiply each of these terms by 4 times x plus 2. So it seems to get a little bit complicated here, but what I like to do is kind of rewrite this so the 4 times x plus 2 gets multiplied through to every term. So I'm going to write 4 times x plus 2 up here again, just so I make sure it gets multiplied to each of these 3 terms. Now, when I can cancel out this entire x plus 2 with this entire x plus 2. Now remember, that 2 has nothing to do with this 4 here. So what I have is 4 times 2. The x plus 2 is gone. It canceled out with the denominator. Here, again, don't forget I have a negative sign. I have 2 goes into 4 twice, but the x plus 2 doesn't get to cancel. And on the other side of the equal sign, I have 4 that goes into 4 once, but again, the x plus 2 doesn't go away. It has nothing to cancel with. So when I clean that up, I have 4 times 2 equals 8. I have 2 times, or negative 2, because of the negative sign, negative 2 times x plus 2. And then on the other side of the equal sign, I have negative 3 times x plus 2. So I would distribute all that. Remember, when you distribute, you have to distribute that negative sign, right? And again here, so that's going to kind of change all the signs when you distribute. I'm going to simplify 8 minus 4. So I have negative 2x. 8 minus 4 is plus 4, equals negative 3x plus 6. I'm going to add 3x to both sides. I can save space. I'm going to subtract 4. I know I'm going to subtract 4 from both sides anyway, so I can kind of do that all in one step. What I end up with here, negative 2x plus 3x is x, and negative 6 minus 4, so those cancel and those cancel, is negative 10. Now again, when you check this, you need to check it in parentheses. Well, good luck to you. I'll see you tomorrow. Tomorrow we'll try some problems. You can ask some questions, and have a great day.